Today we are looking at the definition of a radian and how that's going to come into play with our unit circle. And there's a cool little animation that's going on your slide right now to kind of talk about what a radian is. While that's happening, let's go ahead and get that definition down onto our sheet right away. A radian is a unit of measure for angles. It's based on the radius of the circle. And I'm going to let this animation play one more time through when I'm done talking, and make sure to watch it from the start. But basically what's going to happen is you take the radius of a circle, which is half the circle's width, and then you wrap that radius around the outside of the circle. And that distance that it covers, that angle that it covers, that's equal to 1 radian. You can watch that play out here. Let's notice how that radius is going to wrap around, and that kind of dictates an angle set. That's equal to 1 radian. So there's a couple of kind of tools that we're going to fill out based on this definition of a radian. The first one is this table on the left here. We have some very common degrees: 30, 45, 60, 90, 180, 270, and 360. And we have the radian values. And you notice that these radian values are expressed in fractions of pi. Since the circumference of our circle is going to be 2 pi r, we kind of cut the circle into segments of that. So one of the key things to take away from this table, and please fill out the entire thing so we have it as a reference point. One of the key things, and you might want to circle this, is that 360 degrees is equal to 2 pi radians. So both of them represent one full rotation around a circle. If you rotate around the circle, you've rotated 360 degrees, or 2 pi radians. It's just another way of representing that. The other thing that is already on your note sheet, you don't need to get anything down with it, but is a unit circle. And in this unit circle, all of our angle measures are listed in terms of radians. So instead of 30 degrees, we have pi over 6 radians. Instead of 180 degrees, we have pi radians. So we can use this unit circle just like we've done before with the degree measures. Let's go through a couple of examples on how to do that. So example 1, we have the cosine of pi over 3. So just like we've done before, we take our angle, we go to it on our unit circle, and the cosine is that first value, so we're going to pull that first value there of 0.5. Okay, that second example I'm going to do in blue. We have the sine of 2 pi over 3, so we do a positive rotation. We're going to find 2 pi over 3 on our unit circle, and we're looking for the sine value. So in this case, it's the second value that we're pulling. We're going to have 0.87. And the last one here, I'll do in yellow. We have sine of 4 pi over 3. We move our way to 4 pi over 3 on our unit circle, which is down here. And we're taking that second value, so it's that negative 0.87. So this will not be the main focus today, but another skill that we're going to build is the ability to kind of jump back and forth between degree measures and radian measures. So I want to start getting exposure to that today if we've mastered our use with the unit circle. Because degrees and radians, again, are both different ways of measuring rotation or angles. So the first couple things we're going to look at is converting 2 degrees from radians. So if we were given let's say 5 pi over 6 radians, we would want to be able to convert that to degrees. And the steps kind of look like this. And for the sake of space on your worksheet, I know I didn't give you enough. Let's just do one example today, and we'll come back to more tomorrow so we can kind of cross off that example 5 spot. If we're given 5 pi over 6 radians, we can convert that to degrees by saying, all right, the degrees are equal to our value in radians, so 5 pi over 6. And we're going to multiply it by 180. and we're going to divide by pi. And I should have mentioned this earlier, but make sure that you have this formula, this degrees formula in that box at the top of the section. Pause your screen if you need to get that down. But as we work through this, the first thing that's cool that we can see is that pi shows up on top and bottom of our fraction. So we can actually cross out pi as they'll cancel each other out. And then we're just plugging stuff into our calculator. We have degrees is going to be equal to 5 times 180 divided by 6. So if we punch that into our calculator here, we'll get 5 times 180, divide that by 6, and we'll get 150 degrees. And we'll want to make sure we dictate that with that little degree symbol up top. The other direction we can go is doing finding the radians from a degree measure. So that's going to be this formula in this second box here that we're going to copy to the right side of our notes. So again, we've already handled this degrees side of things. We crossed out example 5. We're also going to cross out example 7 just for the sake of space. And we'll do one example as a class and expand more on it on Thursday. So if we're given a degree measure, let's say in this case 120 degrees. We can calculate the radians by using this formula. So our radians, let's just call that rad, is equal to 120 degrees times pi over 180. Now, we're going to want to express our answer in terms of pi. So let me first rewrite this this fraction. We'll have 120 up top with our pi. So we'll have 120 pi over 180. And we're going to expand these numbers out just like we did with rational expressions earlier, so we can find a simpler form of this. So we can first break down 120 by dividing out a 10, because it'll be 10 times 12. And we'll also be, sorry about that, clicked some random things here. That 12 can then be broken up into 4 times 3, and we'll still have that pi, all divided by 10, and that 18 we can break up into 6 times 3. And we have some stuff we can cross off here. We have 10s up top and bottom, we have 3s up top and bottom, and so we have 4 pi over 6. And I'm realizing just by inspection here, I can simplify that one step further as well. 4/6 is going to be the same thing as 2/3. So our final answer here can be 2 pi over 3.